Hi students, this is Shivakrishna working as a assistant professor in Anurag Civil Engineering Department, Anurag Engineering College. Now I am explain about the unit of design and detailing of footings. In this design and detailing of footings, it should be implemented to what type of footing it should be is supported to total structure, and that total load structure it should be capable to maintain on that particular loads, like dead loads, wind loads, snow loads, and particular live loads. We have to implement that the load should be transferred from slab to columns, beams to columns, columns to footings, and these footings are very capable and very selective and very broad, and this construction, this design are very important to stand up of the total structure. Footing, it is a structural member in that particular building. It supports the column and walls and to transmit the load and distribute that load to the soil, and the load bearing capacity of the soil also not exceeded, and these excessive settlements also not involved in this particular situation. These total settlements and load bearing capacities, these all values are checking, and you have to design on the particular situation. Coming to footings, these two type of footings it should be categorized into different types. That is, first of all, wall footing. These are used to support the walls that carry the loads of the floors or support the non-structural walls. This should be wall footing. The wall should be resting on that footing. Next one, isolated single footings. The isolated means any single footing should have to provide on that particular, that is called isolated. This is used to single columns. These columns are highly useful to only construct the single columns. This is one of the most economical types of footings, and it is used to when the columns are spaced relatively long distances. That type of situation only have to provide on the isolated columns, isolated footings. Next, combined footings, where that soil bearing capacity is very low and loads acting on the pavement on that load bearing is very high. In that situation only we have to provide the combined footing. Combined footing means it is the two columns are combined or three columns not in a row, but one of the main merge the columns, that is called combined. These combined footings are used when two columns, it should be single footing can't be used when one column located near the property lines. And the next one, cantilever or strap footing. In this type of footing you have to provide the reinforcement. This is two single footings connected with a beam, that is called strap footing. Here see here the two columns, two footings should be connected with one single beam. That type of footing it is called strap footing. Next, continuous footing. More than two rows of footings or more than two columns, it should be provided on that continuous footings. Next, mat foundation. Where the soil swelling is very high, the black cotton soils, in that type of soil you have to provide the raft or mat foundations. This is under your soil bearing capacity is very low and column loads are heavy, on that single footing cannot be used in that particular location. That situation only have to prefer the mat footing. Next, pile caps, where the depth of the footing is very high. In the situation we have to provide the pile caps. After that, this total load should be transferred in the soil. This soil should be very high bearing capacity and less swelling nature it should be capable to provide. When the column P is load applied on the central of the footing, a uniform pressure is assumed to develop on the soil surface below the footing area. However, the actual distribution of the soil is not uniform, but depending upon that factors, especially the composition of that soil, degree flexibility of that footing, total how much area it should be, the load should be distributed on that particular situation only the distribution of the soil pressure. See here the different types of soils you have to consider for the distribution of soil pressure. Here the parabola shape should be implemented on that cohesionless soil, and the hyperbola should be implemented on that particular cozy soils. Cohesionless soil means in that situation sandy soils it should be like this, and cohesive like red soils it should be maintained like cozy soils. After that, design criteria. Coming to the design criteria, footing must be designed to carry the heavy loads or column loads to transmit them the soil safety while satisfy the core limitations. What are the core limitations means? The area of footing based on that allowable bearing soil capacity. After that, it should be maintained two-way shear or punching shear, and it should be maintained the one-way bearing also, and bending moment and steel reinforcement should be required. And design considerations after that, to bearing capacity of that columns from that base level it should be considered, and double requirements like steel requirements and development length of the bars, how much development length should be provided on that location, and differential settlement, how much settlement should be acting on that particular structure. And coming to size of the footing, how much size of the footing should be provided on that particular location, that should be determined by depending upon based on the external loads acting on that allowable soil pressure should not be exceeded. That is, area of the footing it should be determined by this expression, that is total load by allowable soil pressure. On that soil pressure, how much soil pressure should provide that is load by area of that footing you should have to complete given the value of that area of that footing. Coming to punching shear, the total area it should be d by 2 from the face of the column. The total load should be distributed on that particular footing area. In that how much area it should be effective on that particular load, that area it should be covered due to punching shear. So here this expression you have to directly substitute in the equation and find out the punching shear values. And next, coming to design of two-way shear or punching shear, this is both are the same, and after that this is the area I have to d by 2 from the face of the column. You have to consider here taken the face of the column from column to all periphery of that situation, how much d by 2 it should be maximize that area you should have to provide. And next one, coming to one-way shear. One-way shear it should be taken as along the x direction and along the y direction only d value from the face of the column. That area should be very highly influenced to the one-way shear criteria. For this situation, one direction of that critical section it should be acting, that is only acting on the d from the face of the column of that both directions you have to consider. Next one, this is the parameters you have to use that, and next one, this is the expression you have to use to find out that one-way shear. And flexural strength, on that bending moment criteria it should be taken as that face of the column. That is the one-way shear and two-way shear. Two-way shear is d by 2 from the face of the column, and one-way shear d from the face of the column. But bending moment criteria it should be considered to the face of the column. By using these areas, you have to find out the based upon the moment conditions, mu by pi fy d minus a by 2. And after that, the minimum steel percentage required for the flexible member is 200 by Fi with minimum area, and maximum spacing of the steel bar should be provided on that particular location. Next one, flexural strength and footing reinforcement. The reinforcement in one-way footing and two-way footings may be distributed across the entire width of the footing. That is, reinforcement in band width by total reinforcement in short direction, it is 2 by beta plus 1. What is the beta here? The beta will be represented, it is the ratio of long side of the footing to short side of the footing. This both values you have to find out, and this total bandwidth should be capable to use the flexural strength acting on that particular location. Next one, bearing capacity of column at base. the loads from that column act on that footing, the base of the column, the area equal to the area of the column cross section, compressive forces are transferred to the footing directly by the bearing on the concrete. These tensile forces must be resisted by reinforcement and neglecting that any contribution by concrete. This is the bearing capacity of that base you have to consider here, that is force acting on that concrete at the base of the column must not exceed the bearing strength of that concrete. What is the formula expression for the bearing capacity of that column? Pi into 0.85 FCA1. Pi means it should be represented as 0.7. You have generally considered here. Next one, development length. From the situation, the development length should be length of the reinforcement should be expanded for improving that column base. We are using the how much length it should be provided on that particular situation by using this expression, that is 0.02 F5 dB by and root FC. This is this formula, this doubles should be checked and a proper development length should be provided. And next one, we have to consider here the some of that movement should be considered on that particular situation. The development length and shear criteria mainly acting on the two main components, that should be how much area should be provided on that particular location, and this how much bandwidth should be provided on that particular location. This total two important parameters to developing on that particular location. This bandwidth very important to development of that particular location and development of that width and cross section of that footing, and reinforcement of that torsional reinforcement, how much it should be provided on that particular location. In here, the types of the payment should be types of the footings should be implemented to different shapes you have to involve, that is square footing, rectangular footing and circular footing, combined footings. Coming to rectangular footing, the area of the cross section it should be only difference between these two total footings, only difference is the area, how much area. For that rectangular footing we have to consider B and D of the total section, and for circular footings I have to consider the pi by 4 d square you have to use, and on that particular situation D value should be implemented on that particular situation. And the square footing breadth and width of that total cross section of that footing should be very less. Most of the cases very low loads will be acting on that particular structure. This type of situation, the square and rectangular, this type of isolated footings may be adapted in that particular situation. And after that, this bearing capacity also, while compressive forces should be transferred to the footings directly by the bearing of that concrete, these tensile forces must be resisted by the reinforcement, neglecting any contribution by the concrete. Why? Because concrete only responsible to compressive forces only. This total tensile stresses, it is responsible to reinforcement. In that situation only, this type of tensile stresses will not responsible to any concrete material. From the situation we have to find out the critical section on that particular footing. We have to consider the neglecting the some area also, that is how much area it should be resisted by the concrete, that should be how to minimize in that particular location. Why? Because it carry only compression loads, that's why only have to provide the reinforcement, means how much tensile stresses acting on that pavement. This pi value should be based upon the bearing area of the column. If the area of that column should be vary, that value of that pi value also it should be vary. The force acting on that concrete at the base of the column, it should not exceed the bearing length of the bearing strength of the concrete. What is the bearing strength of that concrete? 0.45 under root FCK, permissible bearing strength of that concrete. this type of concrete permissible bearing value not exceed in any case. Why? Because if the design of the footing and it should be maintain the bearing strategy, this both are very highly greater than that particular location, and this value of that bearing strength may be multiplied by and the ratio of area 2 by area 1 less than or equal to 2 for this bearing of the footing when the supporting surface is wider on all the sides of that loaded area. What is the A1 and A2 means? You have to different footings you have to provide on that particular location. The area 2 and area 1 should be involved. The modified bearing strength N2 less than pi into 0.85 Fc into A1 into under root A2 by A1. This is the ratio. You should be multiplied with this N2 value, and after that N2 2 pi, that is 0.85 Fc A1. These both values we should be completely study about the bearing stress acting on that particular location. This is the B and D. This total depth it should be how much area it should be affected by critical section, how much area should be not affected by this critical section. This total footing design criteria is very highly influenced to that external loads like all repetitive, all static loads like slab loads, like beam loads, like column loads. These all loads should be transferred to footings only. This total footing should be capable to provide high strength, stamina, and provide to high load bearing area. Okay, these all are very important chapters to study the real practical point of view and realistic point of view, very highly influenced by this one-way shear, two-way shear, and bending moment. These all are very critical to find out the critical section for that particular footing. Okay guys, this total 5 units what beams, columns, slabs, and footings like shear, torsion, this type of one-way slab, two-way slab, these all are very important to design on that particular practical point of view. This is very highly influenced to our civil engineers. Okay, thank you students.